Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter periodic classification. In this session we are going to see about trending of electron affinity and electronegativity in the modern periodic table. What is electron affinity and how it is varying in the groups and periods of modern periodic table. And in the same way, what is electronegativity, how it is being varied in the groups and periods we are going to see now. Okay. Electron affinity is another important property of elements just like ionization potential and atomic size. When an electron is added to an atom, energy is released in terms of electron affinity. Suppose for an atom, an electron is given from outside. When an electron is given to an atom, certain amount of energy is released by that atom after gaining this electron. The amount of energy released there is called electron affinity. When electrons are given to atoms, they release energy out. That released energy is called as electron affinity. It is defined as the amount of energy released when an electron is added to an isolated neutral gaseous atom to form an ion. To form an anion is called the electron affinity. So the amount of energy released when an electron is added to an isolated neutral gaseous atom to form an anion is called electron affinity. So equationally we can show like this. When an electron is given to a neutral gaseous atom X, it forms X minus. Along with that, certain amount of energy is released out. That energy released is called electron affinity, or it is also called electron gain enthalpy. Okay. Just like this, second and higher ionization potentials. Here, second and higher electron gain enthalpies means the second and higher electron affinities are also possible. However, the addition of a second electron to a monovalent anion as to make A2 minus is difficult because both have same nuclear charge and A minus requires energy to overcome the force of repulsions. That means, for example, if you see an element A, if electron is given to that atom, what happens? Then that will be converted into A minus and certain amount of energy will be released out, that we are calling as electron affinity or electron gain enthalpy. Energy is released out. Now this element has become negative anion. Already there is one extra electron. If we give one more electron or if we add one more electron to this negative anion, then what happens? There exists more repulsions between the already existing electrons and this new additional electron, because already there are one extra electron is there. Nuclear charge is less, number of electrons is more in this case, and we are giving one more electron in addition to that. Then what happens? More repulsions occurs. Then instead of releasing energy there, this A minus ion requires an amount of energy. So to overcome these repulsions between the incoming electron and already existing electrons, that is why we say second and higher electron affinities are requiring energy. That means they are endothermic, we can say, whereas first electron affinity is only the exothermic process. Means while taking an electron, all the atoms, they release certain amount of energy, that we call as electron affinity. But while taking second and higher other more than two electrons, atoms, they require certain amount of energy from the surroundings to overcome the repulsions between the already existing electrons and the incoming electrons. That is why we say second and higher electron affinities are endothermic. The second electron gain enthalpy is therefore an endothermic process because it requires an amount of energy to hold these electrons and will be given a positive sign while representing the equations. Okay. Similarly, higher electron gain enthalpy is also not only the second one, second and higher all electron enthalpies are endothermic because they require amount of they need energy for holding these incoming electrons to overcome the repulsions between these already existing electrons and incoming electrons. Only in case of first electron affinity, certain amount of energy is released. In all other cases, higher electron enthalpies, energy is absorbed. Okay. For example, when an electron is added to an oxygen atom to form O minus anion, energy is released because only one electron we are giving. Oxygen will be very ready to gain electrons. So when one electron is given, that will accept that electron and certain amount of energy will be released by that oxygen. That we can call as first electron gain enthalpy, which is released by the oxygen. However, when second electron is added to O minus, even though oxygen is ready to gain two electrons, because it will get complete octet by gaining two electrons. Even though it is ready to gain electrons, but after gaining of one electron, in gaining of second electron, there some repulsion occurs between the electrons in the outer cloud. So to overcome these repulsions, to hold these all electrons, 10 electrons, means already existing 8 electrons, these two new electrons which are coming inside. To hold these all, oxygen needs some more energy. That is why it will absorb energy while gaining second electron. That's why we say second electron gain enthalpy is a endothermic process. While gaining first electron, it releases certain amount of energy out. But while gaining second electron, it absorbs certain amount of energy. Okay. For example, if you see equation it is shown, oxygen while gaining first electron, it will release certain amount of energy. Equationally, it will be shown with a negative symbol that represents a release of energy. Means it is a exothermic process. Whereas if you see addition of second electron to oxygen, it absorbs an amount of energy, so it is shown with the positive symbol, that is endothermic process. Okay. Variation of this electron affinity in the groups and periods. First let us see in a period. As atomic size decreases and nuclear charge increases from left to right in the period, and hence electron affinity values generally increases. Yes, as the size decreasing and nuclear charge increasing, the tendency of attracting or taking an electron into it will be increased because nuclear charge will be very greater as size decreasing. So that can attract the outer electron very easily and hence it can accept. So what happens? It will attract the electrons easily and hence it releases more amount of energy out. So we can say as the size decreasing, electron affinity increases. We know in a period from left to right, size decreases. So we can say electron affinity or electron gain enthalpy in a period from left to right, it increases. Okay. So but actually in a given period, it increases from alkali metals to halogens. So halogen has a highest electron affinity value in a given period. And the inert gases have a complete valence shell. They do not have any tendency to take the electrons. So that is why they don't have any tendency to accept the electrons. Therefore, the electron affinity values of these noble gases are considered as 0. Now we can say in a period from left to right, electron affinity increases from left to right till halogens, that is a 17th group, but it will become 0 for 18th group or noble gases. Now we can say in any period the halogen element is with highest electron affinity value. So this happens in a period from left to right, electron affinity value increases. If you say two elements oxygen and fluorine, so from oxygen to fluorine size decreases, isn't it? And the nuclear force of attraction on the outer electrons will be more. So it can attract that electron very easily and more amount of energy can be released by fluorine. So fluorine is the element with greater electron affinity than oxygen in that period. Okay. In a group, electron affinity gradually decreases from top to bottom in a group due to the steady increase in the atomic radius and the resultant decrease of effective nuclear charge. What happens in case of group? In a group from top to bottom, atomic size increases because number of shells increasing from one element to another element. As size increases, nuclear charge decreases and hence attracting power decreases. So, electron affinity also decreases in a group from top to bottom gradually. Suppose if you see any group from top to bottom, electron affinity values gradually they will be decreased. But there are some exceptions in the p block elements. For example, if you see halogens, the electron gain enthalpy of fluorine is less than that of second element to chlorine. That means actually we are telling from top to bottom it should decrease in a group because size is increasing. But here in the case of halogens, first from fluorine to chlorine it is increasing and from then it is decreasing. Why the second element is having greater value than that of first one? There is a reason, that is these first elements are having smaller size. Not only in this group, in the chalcogen group also we can say oxygen, sulfur, selenium, tellurium and polonium. In these also actually it should decrease from oxygen to sulfur and then selenium and tellurium and polonium should be decreased. But what happens there also, from oxygen to sulfur it increases. Sulfur will be having greater electron affinity than that of oxygen. From then again it decreases to down the group. This is because of the smaller size of the second period elements. So the electron gain enthalpies of oxygen and fluorine, which are the members of second period, they have less values than the third period elements in the same groups like sulfur and chlorine. So this is due to the small size of those atoms of oxygen and fluorine. Even though they have much tendency to attract the electrons, but because of their smaller size, if they gain electron, they should utilize certain amount of energy to overcome the repulsions between the electrons because of their very smaller size. That is why these elements are having less electron affinity than they expected. Okay. If we say, for example, oxygen is having 141 kilojoules per mole electron affinity, whereas sulfur is having greater. Because oxygen is having very smaller size than sulfur. So to overcome the repulsions between the already existing electrons and incoming electron, certain amount of energy utilized by oxygen. So then the amount of energy released will be less than the expected. In the same way, in case of fluorine or chlorine also. Actually, fluorine should have the highest electron affinity, but it is highest for chlorine because of the very smaller size of fluorine. Right? One point you have to note here, it is representing here the energies in terms of negative symbols. That represents just the evolution of heat energy. These are exothermic process which all know. So that is amount of energy is released out. That is represented the negative symbol. And among all the elements in the periodic table, chlorine is the element with highest electron affinity. So we told in any period halogen is the element with the highest electron affinity. In the halogens, the first element is fluorine. Actually, it should have the highest electron affinity, but because of its smallest size, next element of chlorine is having highest electron affinity among all. Okay. Next property, electronegativity. Electronegativity of an element is defined as the tendency of an atom to attract the shared pair of electrons towards itself in a bonded molecule. So the tendency or the behavior of an element by which it can pull the pair of electrons towards it in a bonded molecule. Let us understand this. What happens if two atoms of equal electronegativity bond together. Means if two atoms are combined in a molecule, if both atoms are having the same strength to pull the pair of electrons towards them, what happens then? Let us understand this by taking one example molecule. Consider a bond between two atoms A and B. So in this way, two atoms A and B bonded together by covalent bond formation by sharing a pair of electrons between them. Now, if the atoms are equally electronegative, means both are having the same tendency to pull the electron pair towards them, same force. Both have the same tendency to attract the bonding pair of electrons, and so it will be found an average halfway between the two atoms. To get a bond like this, A and B would usually have to be the same atom or the atoms of same electronegativity. Usually, we will find this kind of bonding in molecules like H2, Cl2, N2, O2. In these all molecules in which a same kind of atoms bond together. There, as they are of same kind, both will pull the pair of electrons towards them with equal force. Then, pair of electrons will be shared by both the atoms equally. Okay, if you say hydrogen molecule, hydrogen will give one electron for bonding, one more hydrogen gives one more electron for bonding. In this way, they share this pair of electrons. But as both are hydrogens, both will pull in the opposite directions with equal force. Then this will be equally shared. That means the electronegativities of these two atoms are same. Generally, the molecules in which both the atoms are same kind will be electronegativity equal. Okay. If What happens if B is slightly more electronegative than A? That means if both atoms are not of the same kind, if one atom is having more electronegativity than the other, then what happens? The atom with the more electronegativity will pull the electron pair towards it till it is lighter. So we told what is meant by electronegativity? The tendency of pulling the electron pair towards it in a bonded molecule is called electronegativity. If we say one of the atoms in the molecule, if it is having greater electronegativity than the other, then it will pull the electron pair towards it much than the other. Okay, then we can say a molecule with the electronegativity difference. To get a bond like this, generally A and B, that means the two atoms usually have to be the different atoms or the atoms with different electronegativities. Then the atom with the greater electronegativity pull the electron pair towards it. The atom with the lower electronegativity will lose the electron pair towards the other element. Okay. For example, we will get or we will find this kind of bonding in molecules like hydrogen chloride, hydrogen fluoride, etc., where one atom is more electronegative than the other. If you see here hydrogen molecule, hydrogen and chlorine, they are sharing one pair of electron each and hence they formed a bond. But here chlorine is being more electronegative than hydrogen. It is pulling electron pair towards it, isn't it? This is because of the electronegativity difference between those two participating atoms. Right? That's about electronegativity. Now, since electronegativity is a relative value, how to measure this? We are going to see here. As electronegativity is a relative value. What we are telling the definition for electronegativity? It is a tendency of an atom to pull the electron pair towards it. Just it is a behavior. So it is not the energy. So that the measurement of absolute value is not possible. So one way of measurement of electronegativity is to take an average of ionization potential and electron affinity. Okay, so actually electronegativity is a tendency or behavior of an element. So the exact measurement cannot be possible. So one way we can calculate or we can compare this. That is by taking the average of ionization potential and electron affinity of that atom, we can measure electronegativity. So this formula we can use. Electronegativity of an element X is equal to ionization energy plus electron affinity by 2. The average of these two will be taken as electronegativity for that element. Of course, there might be some other ways also. In other method, fluorine is taken as the standard and the electronegativity values of other elements are calculated with respect to fluorine. That's another method. But the simple method is according to ionization energy and electron affinity, it is calculated by taking the average of those two. Okay, where here IE representing ionization energy or ionization potential, EA representing electron affinity or electron gain enthalpy in terms of kilocalories per mole. By this, we can calculate electronegativity of an element. So this calculating the electronegativity by taking the average of these two electron affinity and ionization energy was given by scientist Mulliken. So according to Mulliken, now we can say electronegativity is equal to average of these two, ionization energy and electron affinity. If electronegativity difference between two bonded atoms, by this calculation, if you are able to calculate electronegativities, if the difference between the electronegativities of two atoms in a bonded molecule, if it is less than 1.7, then the bond is said to be covalent in nature. If it is equal to 1.7, then the bond formed between them is said to be 50% ionic in nature. And if the electronegativity difference, if it is greater than 1.7, then the bond is said to be completely ionic in nature. Okay, by calculating electronegativity of the atoms in a molecule, we can predict the type of bond between them. If the electronegativity difference between those two, if it is greater than 1.7, then the bond is said to be ionic. If it is less than 1.7, then the bond is said to be covalent bond. If it is exactly equal to 1.7, then we can say it is 50% ionic in nature. Okay, in that way, the nature of the bond can be calculated by using electronegativities of the atoms. Now let us see how it is trending in the periodic table. Variation of electronegativity. If we see in a period, electronegativity increases along a period from left to right. Why? Because the increase in the nuclear charge and decrease in the atomic size. As size decreases, nuclear charge increases, and hence the tendency of pulling the electrons increases. If you see, one period is mentioned here, that is a third period, sodium to chlorine they have mentioned. What is happening from sodium to chlorine? Size decreases gradually. As size decreasing, nuclear charge is being increased. If nuclear charge is greater, the tendency of pulling the electron pairs, electrons towards it, increases. And hence, we can say electronegativity in a period from left to right increases. Okay, what happens in case of group? Electronegativity decreases from top to bottom in a group due to the increase in the atomic size. We know in a group from top to bottom, size increases. As size increases, the tendency of pulling the electron pair decreases, and hence electronegativity decreases in a group from top to bottom. See here the first group elements, lithium to cesium. As we move from lithium to cesium, their size increases. So attracting power decreases, hence electronegativity decreases. In the same way, if you see for halogens also, from fluorine to astatine, size gradually increases. As size increasing, electronegativity values decreases. So we can say in a period increasing, in a group decreasing. So the extreme right side top element will be having greater electronegativity. That is, fluorine is the element with highest electronegativity because noble gases are not having electronegative values, because this electronegativity is compared between the atoms which are bonded. We know noble gases, they do not participate in the bonding itself. So no question of electronegativities for these elements. They don't have any electronegativities. So till halogens we compare. Out of halogens, till the halogens, from alkali metals to halogens, electronegativity is increasing. Among the halogens from top to bottom it is decreasing. So the first halogen is having the highest electronegativity, that is fluorine. Okay. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos.